Hi everybody, in this video I'm going to go over the triangle congruence Google form that you guys had for homework. I'm not going to go over the multiple choice section because when the forms are sent back to you guys through email, you will see the correct answers and the solutions for the multiple choice questions. I'm also not going to go through the last question, which was the proof that you guys had to do completely on your own, because I will put feedback directly on your individual proof on the form, or if you handed it to me in person on paper, I will put feedback there as well. So the first question says, we have triangle ABC, BD is congruent to CD, the measure of angle A is 60 degrees, and the measure of angle C is 25 degrees. The first question is asking me to find the value of angle CBD. So first I need to find this angle over here. That's CBD. So if we take a look for a second at triangle BDC, we see that it has two equal sides, making it an isosceles triangle. Remember, if a triangle has two equal sides or two congruent sides, the angles opposite those sides are also congruent. That's the base angle theorem. So here, opposite from this congruent side is this 25-degree angle. Opposite from this congruent side is this angle. So I know this angle should be congruent to the other base angle of this triangle and should be 25 degrees as well. So the measure of angle CBD should be 25 degrees. The next question asks us to find the value of angle BDC, so this angle right here. Well, now that we know two angles of triangle BDC, we can easily find the third angle by adding the two other angles up and subtracting from 180, since all of the angles of a triangle add to 180 degrees. 25 plus 25 is 50. 180 minus 50 is 130 degrees. So this angle over here is 130 degrees. And I'll write that here as well. The next question asks us to find angle BDA. So angle BDA is this one right over here, right next to the 130-degree angle that we just found. If you think about the relationship between these two angles here, you might see or notice that they form a linear pair, meaning that they are supplementary. So in order to find angle BDA over here, all I need to do is take 180 and subtract 130, and I see that I get 50 degrees for that over here. And finally, the last question asks us for the value of angle ABD. So angle ABD is this angle right over here at the top of this triangle. We know in triangle ABD that we have two angles here, a 60-degree angle and a 50-degree angle. So I can add those up and subtract them from 180 to find the third angle of the triangle. 60 plus 50 is 110. And if I subtract that from 180, I get 70 degrees. So I can put that for the final answer over here, 70 degrees. In this question, we are given a diagram, we're given some given information and what we're trying to prove, and then we need to answer parts A and B. So our given information here is that FH is congruent to GE. So FH is right over here. GE is right over here. And we need to prove that FE is congruent to GH. So here's FE and here's GH. So notice that FE which I just highlighted, is part of this triangle in blue. It's a side of this triangle here. And notice how GH, which I'm highlighting now in green, is a side of this green triangle. So already, just by marking our diagram and thinking about what we're trying to prove and what we're given, we already identified the two triangles that we're interested in here that we need to prove congruent in order to prove FE congruent to GH. And those are triangles, so FHE and GEH. So I see that in this answer choice over here. Those are the names of those two triangles. I realized I didn't mark one of my given pieces of information, which is right over here. HFG congruent to EG. Oops. Let me remark that. HFG. So this angle right over here. Oh no, after I mark these angles, notice how the two given angles are not inside either of the triangles that I marked. That's going to make it really hard to prove these two triangles congruent if some of my given information, and I don't have much given information here, if some of my given information is not part of these triangles. So if you were thinking that it was this answer choice, make sure you mark all your given information. So hopefully that cleared up why it's not this answer choice here. So I'm going to reset here and try to highlight the triangles that include those two angles. So here I have the two congruent angles marked again. And I do want to keep in mind my other given information and what I am trying to prove here. So I am going to go ahead and highlight the triangles that include the angles that I marked, that also include FE and GH, and that also have FH and GE as sides of them. So I can include the given information, and I also need to have triangles that have sides FE and GH as part of them because that's what I'm trying to prove. So the first triangle I highlighted over here has FE, which is what we're trying to prove as one of its sides, and has GE, which is part of our givens, as another one of its sides, and it also includes the congruent angles. I'm going to highlight the other triangle here that includes both of these parts. This triangle over here includes GH, which is the other segment that we're trying to prove something about, and it also includes FH, which we know something about. Notice how the congruent angles are also part of this triangle. So if we take a look at the answer choices, that would be actually answer choice 2. EFG is the green triangle, and HGF is the blue triangle. The next question is asking, how can we prove the two triangles congruent? So let me separate the triangles and draw them separately so that we can mark them separately and see everything a bit clearer. So I went ahead and drew each of these two triangles separately on the side of my paper, and I just marked the given information in the separated triangles, and that makes it a lot clearer. It's kind of hard to mark the first given in the original diagram that FH and GE are congruent, but when I separate the triangles, I can clearly mark FH and GE as congruent to each other. I can also clearly mark the angles and see which angles are part of which triangle. And that makes it a lot clearer what's going on. Since these triangles are overlapping, there's going to be some shared side or angle. So I'm going to look for something that's in common between both. On the original diagram, I see side FG is highlighted in both blue and green. So I can say it's congruent to itself. It's even clearer if we look at the separated triangles, because this is side FG in the green triangle. This is also side FG in the blue triangle. So they're the same side in two different triangles, which lets us know that it's the shared side, the same two letters. So we see here we have SAS, and in this triangle we also have SAS. So once again, SAS, SAS. On the Google form, you should put some sort of explanation as to how you arrived at SAS. We can mention that we have two pairs of congruent corresponding sides and the included angle congruent in between. So we can say FG is congruent to itself by the reflexive property. We can say that GE is congruent to FH from the givens. And we can say that angle HFG is congruent to angle EGF from the givens as well, giving us the information for side angle side. Here we have a fill in the blank proof. So before we go filling in the reasons over here, going to just take a look at the givens and try to mark the diagram. So it says N is the midpoint of MP. So I see that there are congruence marks on MN and PN. QN is perpendicular to SM. Here's QN. Here's SM. And I see a right angle was already drawn in for us. RN is perpendicular to SP, and I see a right angle was already drawn in for us. And QN is congruent to RN. They already marked those as congruent for us. So the diagram is already marked for us, and our goal is to prove that the big triangle MSP is isosceles. So remember, in order to prove something's isosceles, we have to prove that it has two congruent sides. So our goal is going to be to show that the big triangle has two congruent sides. Let's figure out how we're going to do that. So I see two triangles, two smaller ones in my diagram, and they're both right triangles. I see in these two right triangles over here, we have congruent hypotenuses and a pair of congruent legs. So already I'm seeing that these triangles can be congruent by HL. If we know the triangles are congruent by HL, we can make the statement that the corresponding angles are also congruent by CBCTC. And by the converse of the base angle theorem, if a triangle has two congruent angles, the sides opposite are also congruent, making the triangle isosceles. So that's the plan. Let's write it up. Let me undo this so I don't confuse anybody, but that's the plan here. First up is the givens. That is the given information. So how did we know that we have right angles? Well, that comes from perpendicular lines in the given. So I'm going to write here, perpendicular lines form right angles. How did we know that N is the midpoint of MP? Well, that was given to us. So let me write given here. That's where I got that from. How did I know that MN was congruent to PN? Well, we know that N is the midpoint of MP. So MP is being split into two equal parts. And those two equal parts are MN and NP. So we know this because a midpoint, I'm going to put dot, 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 because we all know this by now. A midpoint splits a line segment into two congruent parts, or equally in half. How do we know that QN is congruent to RN? Well, that was given to us. That's where we got that from. How do we know the two triangles are congruent? That is by HL. How do we know that angle M is now congruent to angle P? Well, we just proved the triangle is congruent. So we know that due to CBCTC. How do we know now that SM is congruent to SP? Well, in the big triangle, we now know that there are two congruent angles. So the sides opposite those angles are also congruent. So I'm going to write here, if angles of a triangle are congruent, then the sides opposite are congruent. So you can see what that reason looks like written out. That's the converse of the base angle theorem. And then finally, we know that triangle MSP is isosceles because it has two equal sides. A triangle with two congruent sides is isosceles. So you might have noticed that there's something missing from this proof, so I just want to acknowledge it in this video. In order to use HL, remember that the very first thing you need to know about the triangles is that they're right triangles. So in the proof in step 2, we mentioned that we have right angles from the perpendicular lines, but there actually should be a step after that that actually says triangle MQN and triangle PRN are right triangles. And your reason can be a triangle with a right angle is a right